So June 2021 MCQs. A detector and a counter was placed near a radium source and the student measured the count for 1 minute. Which of the following would increase the accuracy of the student count rate? Adding a background. No, not adding a background. That's wrong because we should subtract the background. Increasing the counting times to 10 minutes. Recording for a long period. We want accurate values from the source, so it won't affect. Repeating the counts with a different detector and calculating a mean, that does not make much difference. But significant difference when subtracting a background count from the measured count, we can work out the counts from the source. So D will be the right answer. Initial value determined by the astronomers for the Hubble's constant is smaller than the current accepted value. Which of the following statement is correct? So Hubble constant and the age of the universe are inversely proportional. So when we check the options, the which of the following statement is correct? Universe is bigger than the astronomers initially thought. If the universe, because if you see the initial value determined by the astronomers for the Hubble constant was smaller, means this was smaller, so the time which we get for the age of a universe is greater. And if the time is greater, it means like it for a very long time the universe is expanding, so the size should be greater. So the statements which explain this rate of expansion, because the main idea what Hubble's constant give an idea, it's about the time interval rather than the size of the universe. Like it's a Hubble constant shows a relation between a time and the, like how much time the universe take rather than directly size of the universe. So they did not, the universe is bigger than the astronomers initially thought. Universe might be bigger, might be smaller, but the Hubble constant does not give idea about the size. It gives the idea about the time, like it was older or younger. So the universe is not old as the astronomers thought, because like in when they got the smaller value of the Hubble constant means they got a longer time. So initially the astronomers thought that the universe is much older than what is actually is. That's why statement B explain why the smaller value of Hubble constant we get. The universe is older than the astronomers. The universe is older than astronomers initially thought. So if the universe was older, the time will be longer. But this is correct. The value has been corrected. Like how the two statements are different from each other here. The universe is not as old as astronomers thought. Because if the universe was old, then the Hubble constant value should remain smaller. But because the value is higher, it means the time in for the age or the age of the universe is smaller. But this is like universe is older, universe is not older. If it is older, then the value of the Hubble constant should remain smaller. The universe is smaller than the astronomers initially thought. The size of the universe, again, the Hubble constant does not indicate about the size. It's mainly indicate about the time. Because there is no scale to say size of a universe is small or big. It's about the time interval. Size of the universe we can estimate by using the average density and the actual density, comparing actual with the average density, then we can compare the size. In question 3, when a train travels across a railway bridge, the bridge may be forced into a resonant oscillation. Suggests which of the following would happen only when resonance occur. Resonance means when one object forces the other object to vibrate, we call that as resonance. And damping reduces the amplitude of oscillation. That is true statement, but not about resonance. This statement is not wrong. Damping reduces amplitude of oscillation, or it also in natural frequency also it reduces, but it's not explaining the idea. Energy is transferred from train to the bridge. The bridge may be forced to resonate. So why energy transfer? That's also correct, but only happen when resonance occur. Like energy is transferring, even resonance is happening or not happening, it occur. Resistive force dissipate energy from the train. That's also. But when resonance happen, which only happen or occur, the amplitude of the vibration will be maximum. That's why at a resonant frequency, when we sketch a graph for amplitude and the resonant frequency, as we increase the frequency, amplitude increase, and then again, so the amplitude of the vibration is maximum at the resonant frequency. Others are happening, but this only occur when the frequency is equals to resonant frequency, the applied frequency or the forced frequency. Question 4, in the sun, the nuclear fusion occur mainly in the core. Which of the following is the reason? You can also use the chat if you want to participate. You can use the chat. I'll explain. In the sun, nuclear fusion occur. Which of the helium nuclei surround the core? Most of the sun hydrogen is in the core. They mentioned the sun occur mainly in the core. So what is the reason for because for a fusion, helium nuclei have a greater nuclear repulsion than hydrogen. So they need more energy to fuse. Helium nuclei surround in the core. That is okay. Most of the sun hydrogen is no. That's not. Core contain most of the mass. That is true, but the temperature is greater in the core because high temperature will be enough to overcome the intermolecular force. But helium and this statement will true when the sun will become a red giant. Like it's not like most of the helium is there in the core, but a fusion when the sun become a red giant, then this will be true. The gravitational field strength of the sun or on the surface of the Mercury is Gm. Callisto, a moon of a Jupiter, has the same radius as a Mercury, but only 1/3 of its density. What will the gravitational field strength? So, if we compare the gravitational field strength, and it has the same radius, so the value G is equals to capital G mass over R square. And if they have the same radius, means the size is same. If I rearrange this equation, like radius of the Mercury is equals to Gm over mass of a Mercury. And for radius of our moon will be Gm over mass of the moon. Now, in the question, the they have same radius is there. So if you talk about like the relation between Gm over R square is there, R is constant. But what about the density is mass over volume? Their volume is same. as I mentioned, because same radius, the volume will be same. What will the relation between density and mass? Density and mass are directly proportional. The Callisto, a moon of a Jupiter, is 1/3 density. Like its density is divided by 2, or divided by 3, 1/3. So mass is divided, because if density is divided by 3, the mass should also be divided by 3. So if we compare, so it will be Gm over R square. G is constant, R is constant. But what happened to the mass? The mass is divided by 3. Why mass is divided by 3? Because the density is divided by 3 and the volume is constant. So if the density is divided by 3, what happened to the gravity? Or the gravitational force? The gravitational force will also divided by 3. So it will be, compared to that of Mars, it will be G by Gm, like gravity of a Mars divided by 3. Next, Tau Centi is one of the closest star to the sun, has a surface temperature of 55,300 Kelvin, and the luminosity 0.55, the luminosity of the sun. Which of the following is a correct description? So when we have a Hertzsprung and Russell diagram, this will be a temperature in a decreasing scale, and this will be the luminosity. Like these are the main sequence star. Temperature is on the higher side. Sorry, temperature 5,000. Usually, like when we write, like it will be like 24,000, then 12,000, then 6,000, then 3,000 will be there. So somewhat here. And the surface temperature. And the luminosity is 0.55, like smaller than that of the. So temperature in this range and the luminosity is also long, like low temperature, low luminosity. So means it is, because main sequence star, if the luminosity is low, temperature is low, luminosity low, temperature high, luminosity high. If it was a white dwarf, then what should happen? Temperature should be high, but the luminosity should be low. If it was a red giant or a supergiant, then the temperature should be less and the luminosity should be high. But this explains that it should be a main sequence star. Why main sequence? Because red dwarfs are wrong. Red giants are there, but if it was red giant, then the luminosity should be higher. And if it was a white dwarf, then the temperature should be higher. So it's a main sequence which shows low temperature, low luminosity, high temperature, high luminosity. Helium is closed in a cylinder until the pressure exerted by the helium is 4 times the original pressure. The volume stays the constant. The root mean square speed of a helium before heating is V. The root mean square after heating is Vf. So what is the ratio between root mean square speed? The pressure has changed. So if the volume is constant, it means the pressure and temperature are directly proportional. If the temperature is directly proportional to pressure and the pressure is double, pressure 4 times, sorry. So if the pressure is 4 times, means the temperature should be 4 times. And temperature is kinetic energy, which is half mv square. Mass is not changing. Mass is not changing because it's the same. So what should happen to the speed? The speed should be double. Because if speed is double, 2 square will be 4. And but the question is, what happened to ratio of v square? So what, speed should be double, but what happened to the v square? Because like temperature is directly proportional to half mv square. So the question is not what happened to v. The question is what happened to the ratio comparative. So what happened to v square? The v square should be 4 times. V should be 2 times, like speed should be double, but the v square is 4 times because temperature is directly proportional to v square. So if v is double, v square will be 4 times. If v square is 4 times, temperature is also 4 times. If the same question was there, what happened to V? Like this was a question. Then what will be our answer? Our answer will be B in that case. But the question is what happened to Vf square, the final speed square? So the final speed square is actually 4 times because the temperature is 4 times. So read this properly. Two stars are there, approximately same radius. The surface temperature of P is twice as Q, and star P has a luminosity LP, star Q has a luminosity LQ. What is the ratio? So luminosity is 4 pi d square sigma t raised to power 4. If it was about root mean square speed, then also we'll say double. Like root mean square speed also means like this, which is V. So if they say what happened to root mean square speed, we'll say double. So 4 pi d square. So two stars, approximately same radius. So this factor is constant. Surface temperature is twice. So if surface temperature is twice, 2 raised to power 4, 2 multiplied by 2, 4 multiplied by 8, multiplied by 2, 16. So this will become 16 times. An object oscillates with a simple harmonic motion. The period of oscillation is 0.55, amplitude 0.25. Correct for maximum. Maximum speed V is equals to R omega is there, or A omega you can say. Amplitude is 0.25 and omega is a period of oscillation. So omega is 2 pi divided by T. And T is 0.55. So 0.25 multiplied by 2.5. So 0.25 multiplied by 2 point divided by 0.5. So it matches with option because the formula is V is equals to A omega. A is the amplitude and omega is 2 pi divided by T. Two stars are there, which are black body. The graph shows how the variation. The star are both viewed from a same distance. Which of the following statement is correct? So star Y will have a high temperature because the peak will decrease and it will shift towards right. So this will have a high temperature. This will have a low temperature. Because when we increase the lambda max, this will be the lambda max and this will be a lambda max. The peak wavelength that is refers to a lambda max. Star X is brighter. Okay, sorry. This is a wavelength graph by mistake. I thought it was a temperature. Yeah, because see the relation between lambda max and T, they are inverse. So what will happen if this is a lambda max for X? So lambda max for X and this is lambda max for Y. Lambda max for X is smaller. So the lambda max of X is smaller means it should have a high temperature. So this is a wavelength graph. If it was a Maxwell-Boltzmann graph for temperature, then opposite will happen. Like if we increase the temperature, peak will shift toward right. It was temperature. But this is not temperature, this is lambda wavelength graph. So lambda max for X is smaller, so it means it has a high temperature. And if it's a high temperature, then it will be both have the same distance. So luminosity is 4 pi r square sigma t raised to power 4. So temperature is high. So luminosity of X should be higher. So X star will be brighter because it has a high luminosity as we are observing them from the same distance. Is it clear? Question 10?